different things that can happen at the end of a graph. And so I've got this little table. I give you guys this little table like on a test or quiz. And that's based on the degree, which is the highest power of x, and whether or not the leading coefficient is positive or negative. So I just did like the most basic version of each one of these to give you an idea of what it would look like. So odd in terms of being the degree, I just have like just y equals x, right? Just y equals x. There, it's to the first power. You're not going to see that written in there, but it's odd. And it's positive. And again, it's not written in here, but this would just have like a little positive 1 in front of the x squared. So that's positive because of the positive 1, and it's odd because the exponent's odd. So I'm just going to sketch this. It doesn't have to be perfect. So if you just had y equals x, right, you'd start at 0, 0, and then go up 1 over 1, up 1 over 1. It's a perfect diagonal through the first quadrant and the third quadrant. I'm just doing a sketch here. It doesn't have to be perfect. What I'm talking about in this part is the end behavior. So any odd graph that has a positive leading coefficient, on the end, on the right side, is going to go down. So like the far right, or sorry, I'm backwards from you guys. On the far left, it goes down. So that side of the graph, the end behavior goes towards negative infinity. And then on the right side of the graph, the end of the graph points up forever, and so that goes to positive infinity. All right, so opposite directions whenever you have an odd degree. So one goes down and one goes up. Now, if I give you most basic negative odd, right? So I've got a little negative out in front of the x, so it'd be negative 1x, and then it's not written in here, but to the first power. So that would be an odd degree. One would be an odd degree. This would just be a perfect diagonal here. Like I'd start at 0, 0, go down 1 over 1, down 1 over 1. It literally just flips that line over that we just graphed. And so the end behavior of this one is different. The end behavior here, I go up towards infinity on the left side, and I'm going to go down to negative infinity on the right side. The main thing to remember with odd functions is they both, or like they go opposite directions. So I think odd immediately, like if you see a 1, a 3, a 5. Opposite directions for the ends of the graph. If you have an even function, so I just have positive and even, most basic version of that would just be a quadratic. So y equals x squared. So this is just, you know, positive 1x squared. You guys hopefully remember the shape of this, just like a little U shape. It would go through the origin. If I had specific points, I could do my 1, 3, 5. I'm not worried about that here. I'm just worried about what we call the end behavior. Now, if it's an even function, both ends of the graph will go the same direction. So for this one that I have drawn here, if it's positive and even, both ends go up to positive infinity. If we throw a negative in front of that, that flips the graph over, so just negative x squared, and just in general, that looks like this. The vertex would be at the origin, but both ends of that guy go down. So both left side and right side go to negative infinity. So the odd ones are always tricky. The odd ones go opposite directions. The even ones go the same direction. So we're going to draw these on some graphs with some specific information and not so basic as what I've got up here at the top. Okay, now whether it's positive, negative, even, or odd is based on what we call the leading term, which would give you the degree and then also whether it's positive or negative. Now, I left almost all of these today in factored form just to help us. That'll make more sense in a second. But if I multiplied out, like we were doing yesterday, so I have x minus 5, x minus 1, x plus 2. If I multiplied that all out and I put it in standard form, does anybody know what the very first term would be that you would write down? If I multiplied it all out, or do you know how to, Colton, what do you think? Yes, okay, how did you get that? Exactly, yes. If you're not sure, it would literally just be, if I foiled this completely out, it'd take us a couple minutes to do it. We're not going to do that. If you just multiply the first term in each of those little sets of parentheses, that will give you the leading coefficient. So just x, multiply that together will give me x to the third. There's nothing that's making that negative. So this is going to be positive because I don't have a negative in front of it. And the exponent is 3. So the exponent is the degree, and 3 is an odd number. So this will be positive and odd. All right, so from my end behavior, this is going to act like a line that has a positive slope. So it's going to go down at the beginning of the graph and then up at the end. Okay, the other thing I got to pick out from this equation is what are the zeros. So if you're looking at this, can anybody just tell me from the factored form, like what would the zeros be for this graph? What would the, go ahead. Exactly. Okay, so 5 here, -1 here, and -2 here. All right, so I know this is where the graph is going to somehow interact with the x-axis. So all we're going to do, just come down to your graph, and I'm just going to put a dot on each one of those values on the x-axis. So -2, oh, fail, this is +1, I'm sorry. -2, we're good, +1, and +5. Okay, now, just remember this doesn't have to be perfect. I do want to see the correct zeros there, so I should see the graph at -2, 1, and 5 going through, or touching the x-axis. Now, I'm going to use my end behavior. So I know on the far left, it's going to go down. So I'm literally just going to sketch so it goes down. That's it. On the far right, it should go up. So that's on the 5. I'm just going to go up. Now, this is where we're just going to sketch. You see, I don't even have the y-axis labeled here at all. These are not specific points other than the zeros. You're literally just, you're just going to kind of wave through each of these points. So, like, I'm going to go through the -2, but I know I have to come back down and go through the 1. And then go ahead, go through the x-axis, and then you know you have to come back up to go through the 5. And it's just a sketch. Like I said, our graphs might look a little bit different, but the ends should be the same, and I should go through the correct zeros. We're not plotting specific points other than the zeros, so we're just going to have kind of like a wave through those, and that's all you have to do. Just a sketch. Is anybody having a question? Okay, if I multiplied out the -x times x minus 3 times x plus 3, can you tell me what the leading, like what would the first term be if I wrote it in standard form, if I multiplied those 3 out? What do you think? Yes, so I've got -x, x, this would be -x cubed. Now, that little negative makes this negative, and the 3 makes it odd. Now, if you have negative and odd, that's going to have the end behavior. It's going to look like a line with a negative slope. So that should actually go up at the beginning and down at the end. Now, I got to have my zeros so I can put this on the graph. What would my zeros be for this particular equation? What do you think? 3, -3, anything else? 0. Okay, you probably said that and I'm going deaf. All right, so we're going to put those 3 numbers on the x-axis. So -3, 0, and 3. And I always start with the end behavior. So whatever is on the far left, that's supposed to go up at the end. So up, or sorry, at the beginning, I guess, on the left side. And then on the far right, we're going to go down at the end. And then you're literally just, we're just going to kind of like make a wave through these. So I'm going to go through my x-axis, but I have to come back up and go through the origin. Go through the origin, but then you know you have to come back down to go through the 3. So just to sketch something like that. It doesn't have to be perfect. I'm just looking for the correct zeros and the correct end behavior. That's it. Is anybody having a question? Scooch this up. Now, can you tell me, and again, I'm not asking you to multiply all this out. I just need the leading term. So it should just be the first term in each of the little factors that they've got there for you. What would the leading term be if we multiplied this one all out? X to the 4th. You got here 1, 2, 3, 4. X to the 4th. Okay, now positive. Nothing making that negative, so this is positive. And because I've got a 4, now we've got an even. If you have an even function, both ends go the same direction. If it's positive, they're both going to go up. All right. What are my zeros for this graph? Don't everyone volunteer at once. Go ahead. What were you going to say? 0, 3, negative 2, 5. Okay, so we're just going to put those guys on the x-axis. So I'm going to go negative 2, 0, 3, and 5. Okay, whichever one on the graph is on the far left, which for this graph is going to be the negative 2, the end behavior there is supposed to go up. So I'm going to draw up on that. And whatever's on the far right, for this graph, it's going to be 5. We're going to draw up on that as well. Now, all you got to do, we're just literally going to like wave through each of these points. So I'm going to go through the negative 2, and then I got to come back up and go through the origin. Just kind of try to make it like a curve as you go through. So you go through the origin, you can go back down, and you got to go through the 3, and then I got to come back up and go through the 5. So something like that. Does not have to be perfect. I'm just looking for, do you go through the correct zeros and do you have the correct end behavior? Does anybody have a question? Okay, now this last one's kind of tricky. So I have negative x times 2x plus 5 times x minus 4 and times x minus 2. If we multiplied that all out and wrote the answer in standard form, what would the first term be? If I multiplied all that out. She's close. She says negative x to the 4th. The 2, yeah. Negative 2. Because you got, see the 2 right here? This is tricky. So negative 2x to the 4th. Now, this guy then is negative because of the negative 2. But it's still even because my exponent is 4. And if it's even, both ends go the same direction. If it's negative, we're both going down. Okay, now, not all of these are nice zeros. So just that negative x out in front, that'll just be 0. What would the 0 be if I've got 2x plus 5? Heck yeah, negative 5 over 2. Now, to me, and you guys might be different than me, but I'm like, I don't really know what that means when I'm thinking about a fraction all the time. So if this helps you in any way, if you do end up with a fraction, I usually just write it as a decimal. So that's negative 2.5. And we can just kind of estimate where that falls on the graph if it's not a nice number. Just, it doesn't have to be perfect, but that just kind of go right in between the negative 2 and the negative 3 is what I'm going to do for that. And then we've also got a 4 and we've got a 2. So those are the points I'm going to plot. So like I said, for the negative 2.5, just do your best to kind of go between the negative 2 and the negative 3. It doesn't have to be perfect. And then I've got 0, I've got 2, and I've got 4. Whichever one's on the far left, we're going to draw down on that. That's going to be that negative 2.5. And whichever one's on the far right, which is the 4, we're going to draw down on that too. The two ends should both go down. And then you're literally just going to make a little wave through your x-axis. So I'm going to come up, but I know I've got to come back down through the origin. Go through the origin, but I know I got to come back up through the 2. And then I got to come back down through the 4. So just making a little wave. Is anybody having a question? Okay. Now, I haven't given you guys anything that has a multiplicity, so I'm going to talk about that with you guys on the back. The multiplicity does affect how you would go through a graph. All right, so I'm just going to make up like a little teeny tiny example. If you have an even multiplicity, so that just means I'm going to have an exponent on my little factor that's an even number. It's going to do what we call create a bounce. So a bounce, basically what you do is you bounce back off the x-axis, whatever direction you came from. You're going to bounce back. Okay, so you don't go through the x-axis, you're going to go back and bounce the direction that you came. So I'm just going to make up like a tiny example. Let's say, I don't know, let's say we had x minus 2 and that was squared. All right, so my multiplicity there would be even because it's squared. This is what it would look like. So I would just go over to, this would be, the 0 would be positive 2. And what it would look like, instead of going through the x-axis, I bounce back the direction that I came. So I touch the x-axis, but I don't go through it. So anytime you have an even multiplicity, don't go through the x-axis, you're just going to bounce back the direction that you came. All the problems we did on the front had an odd multiplicity. And we usually don't identify a multiplicity if it's just to the first power, but I just put that up there. That includes 1. So if you just have a plain x, or if you have like in parentheses x minus 8 or something like that, it goes through the x-axis. But just to give you another example, what I mean by goes through the x-axis, let's say I had, I don't know, like x plus 3, and that was to the 5th or something. As long as that exponent is odd, I'm just going to go like 1, 2, 3 to the left here. My 0 would be at -3. And you would go, kind of turns, it's not like a line, it kind of turns and curves a little bit for an odd multiplicity, but you're going to go through the x-axis. That's basically what you need to remember. So if it's odd, you're going to go through. Yeah, it's an x cubed is what it kind of looks like, but yeah, it does look like a snake. We're just going to sketch these so it doesn't have to be perfect, but I want to put that on there for you. It does look like a snake. Okay, so again, we are not multiplying these out, but these can be tricky to find the leading coefficient. So I have a little negative out in front, and then I have x plus 1, that's squared, and then I have x plus 4, that's to the 3rd. If you multiplied that all out, that little negative out in front is going to make this negative. Do you guys know what x to what power would it be? To the 5th. I know that's super tricky. So this is twice, right? X twice, and this is x 3 times. If we sat there, and you don't have to, here, I'm just going to do it real quick. This would be x plus 1 twice, and then we'd have, bless you, x plus 4 3 times. So if I did multiply that all out, we would end up with our leading term being x to the 5th. All right, now, that is going to make this negative, obviously, and also odd. All right, so end behavior for odd. Odd goes opposite directions. If it's negative and odd, it goes up at the beginning and down at the end. Now, I only have 2 zeros here. I have -1 and I have -4. So I'm going to come down to my graph here real quick. -1 and -4. Now, the only thing I have to worry about is if my multiplicity is even, and I have an even multiplicity from that exponent being 2 at the -1. All right, so this one, and you guys don't have to, this is just what I do. So the -1, I know I should have a bounce there because that's even, so I don't want to go through the graph at the -1. So I usually just like circle it or something so I know I'm going to bounce back the direction that I came. I'm not going to go through the x-axis because that has an exponent of 2. Now this one, the x plus 4, that has an exponent of 3. That's odd, so you do go through the x-axis. All right, so I'm going to put my end behavior in here. I know this is supposed to go up at the beginning and down at the end. Now, at the -4, we have an odd multiplicity, so I'm going to go through the x-axis, but I'm going to come back up because I have to go through and touch. We're not going to go through, sorry, we're going to bounce off the -1, and then my end behavior is already going to make me go back the correct direction. So only if you have a bounce, you just bounce. So I was coming at the -1 from this direction, I just bounce back the direction that I came. So something like that. Can anybody tell me what my leading term would be for, I've got x squared, x minus 4, and x plus 3. Like if we multiplied that all out, what would the first term be if we wrote it in standard form? Heck yeah, x to the 4th. All right, so nothing making that negative, so this is positive. The 4 is even. All right, now if it's even, both ends go the same direction. If it's positive, they're both going to go up. All right, so my zeros. 0 from this out in front, 4, and -3. Do I have an even multiplicity on any of those? It's so tricky. I know. Usually it's on the parentheses. If you have a plain x out in front and it's got an exponent, this does have a multiplicity of 2. So I will have a bounce. I don't want to go through because that's an even multiplicity, so we're not going to go through on the 0. So I'm going to put these guys on the graph. So I've got -3, 0, and 4. And I'm just going to put my end behavior in first. So both left and right should go up. And if you want to, I know I want to make sure I don't go through the x-axis at the 0 because that's going to be an even multiplicity, so I'm going to have a bounce there. So the other two, at the 4 and the -3, those both have odd, or they're just to the first, but they're odd multiplicities. So like here at the -3, I'm going to go through the x-axis. I have to come back up and touch the origin. I'm just going to do my best. This doesn't have to be perfect, but it should kind of make like a upside down parabola here. But at the 0, I'm going to bounce back the direction I came. Then I have to come back up because I have to go through the 4. So something like that. If you have a bounce, just don't go through the x-axis, just go back the direction that you came. If you put the end behavior in first, it should kind of force you to graph it correctly. And then the last two I have here, these we're going to graph. The only difference is these are not in factored form. They're in standard form. So we're going to kind of practice what we were doing yesterday and factor these a little bit. The one thing that's nice, if it's in standard form, I can just see the leading term here should be x to the 5th, and on this one should be -x to the 4th. So I'll know my end behavior right away. This is positive and odd. So this is going to be down at the beginning, up at the end. This one is negative and even. So it's going to both, if it's ever even, they both go the same direction. So they're both going to go down. Odd goes opposite directions. Okay, now the problem with standard form is I can't see the zeros really easily like I can in factored form. So we're going to factor it so we can figure out what the zeros should be. All right, so if I'm looking at this lovely equation here, what do x to the 5th, -6x to the 4th, and 9x cubed all have in common? X to the 3rd, right? Everybody has at least x to the 3rd. So I'm just going to pull that out in front. Now, left over, we're going to take 3 x's out of each one. So we'd have x squared minus 6x plus 9. And then what you're going to have in there, in the parentheses, we can factor that a little bit more. Can you all think of two numbers I'd multiply together to get 9, add together to get -6? -3, -3. Okay. Now, because those are both the same, if you want to just skip that step and just go ahead and write x minus 3 squared, that is going to be important to put together because that's going to create an even multiplicity. All right, so the 2 means, on that, means we're going to have a bounce. I'm throwing things, sorry. So, let's grab a different color here. So 3, but I'm going to have a bounce on that. And then I have x to the 3rd, that would just be 0 as my 0. Do I have a bounce on that? No, because that's that 3rd power, that's odd. If it's odd, you're going to go through the x-axis. If it's even, you're going to bounce. All right, so let me put this on the graph. So I just have an x value at 0 and at 3. And just to remind myself, I'm going to put a little circle around the 3 so I don't go through the x-axis. I want to bounce back the direction that I came. So my end behavior on the far right or far left, I should go down. And on the far right, I should go up. And this kind of going to force you to go the correct way. So I'm going to go through the origin. That was an odd multiplicity, but I got to come back down and I got to touch the 3. But at the 3, we got an even multiplicity, so I'm just going to bounce back the direction I came. I already had my end behavior in there, so I didn't have to do much with that graph. Does anybody have a question? Okay, I got one more. And this last one is the trickiest for factoring. So I have -x to the 4th plus 16x squared. Does anybody know what should I take out in front of, they have a greatest common factor. What would you take out in front of both of those terms? I've got -x to the 4th plus 16x squared. Okay, she says x squared. Would anybody take anything different? Yes, okay, that's what I was trying to get you to do. Okay, I'm going to take out a negative x squared. Now, the reason for that, whatever we have left in the parentheses, we're going to see if we can factor that any further, and you really want that to start with a positive if you can. So, because this started this way, I would just divide both of these by negative x, I don't know why I just wrote to the fourth, negative x squared is what I'm going to take out of both of those. Now, it's going to change the sign. This would then become positive x squared, and this would become negative 16. And that's what I want to do. If you are going to try to factor what we have left in the parentheses, which we're going to have to do on these questions, you want that first term to be positive. Now, I don't know if you guys remember doing these. Can you think of two numbers multiply to give you negative 16 and add to give you 0? Caleb, we can. 4, negative 4. So that way, if I take that negative out, then we have a difference of squares. If you don't take the negative out, you're not going to notice that. Okay, so I have, what are my zeros here? 0. Now, that has an exponent of 2, so we'll have a bounce on that one. And then I have negative 4, positive 4, no bounces on either one of those. So just plotting those 3 points, negative 4, 0, and 4. And I'm just going to put a little circle on mine to bounce at the 0 because that has an even multiplicity. Now, my end behavior, I wrote this like 5 minutes ago, I feel like. So negative and even, because I have negative x to, bless you, negative x to the fourth as my leading coefficient. So down on both ends. Now, I'm going to go through the odd multiplicity. So go through the negative 4, but you got to come back down and touch the origin. Now, when I do this, I'm going to bounce back. Just try your best. You're going to try to kind of create like the shape of a parabola here. Bounce back, but then you know you got to come back down because you got to go through the 4. So the bounce is at the 0, and I'm going through on the 4 and the negative 4. Is anybody having a question? It's